All right, this one is a little tricky. So the first one, they give you a hint, and the hint they give you is that, so you're given these probabilities, and they give you this hint that probably, the probability of B, this is actually incorrect. So they give you this thing with A and B, but what's confusing here about this is that there's an A and B here. What they intend here is that this is not the same A and B. So let me show you what I mean. If I have so this is number 2. If I have a set A and I have another set B inside there, then the B that's inside there, the probability of that B has to be smaller than that probability of the A. Probabilities are not sets. There's a reason for this. There's a proof for this. And you can actually prove it, but I'm not going to. But what you can say is if, and I'm just going to call these things something else because I don't like that they're mixing the A's and the B's to abuse. But if I have one set is S and the other set is T, if T is inside S, then the probability of T is less or equal to probability of S. That's true. And so we're going to use that with substituting T and S for this A intersect B. Now, the observation you need to make is that if I have A intersect B, here's A, here's B, A intersect B is a subset of both. So A intersect B is a subset of A, and A intersect B is also a subset of B, which makes sense. These guys, A intersect B with the football region is shared by both A and B. So it's got to be inside. And this little thing means subset. It means inside, entirely contained. That's what that means. It's got to be, and it looks kind of like a fat less than sign. That's not an accident. We kind of think of them as less than. So it's a notation that's kind of supposed to be reminiscent of less than. It's not the same because I have sets. Okay, so with that, I know that by this law up here, that the probability of A intersect B has to be smaller than or equal to probability A. And I also know this. By substituting in here, T is equal to A intersect B, and S is equal to A, or B for the second version. So if I look at up here, could it be the case that probability of A intersect B equals 0.5? Well, no, because then 0.5 is not smaller than 0.3. So if I go down to this list, there's 3 no's. The first no says this is not possible because A intersect B is contained. And you see exactly what I just said. I don't know how to do this without actually giving you the answer, but I wanted to show you this. This is why it's hard to make an automated question for this. But I do feel like this is tough without actually going through it. So now they say assume that the probability of A intersect B is equal to 0.2. What is the probability that the selected student has at least one of these 2 types of cards? So let's draw out a diagram. A is the students that have a Visa card, and B is the set of students that have MasterCards. And the question is, what is the probability that the selected student has at least one of these 2 types? That means they have to be in either A or B. So how do I get that? Well, there is in your book, I think they call it a certain thing. I'm going to look up what they call it. They call it a name. I think they call it the subtraction law. They call it something that I don't recognize. Looking at it, hang on one second. I want to make sure I don't do another thing where I give you, it's called the addition rule. So I knew, I don't want to call it something that's called different in your book. So the addition rule says that, so what I need is that at least one of these two types of cards means it has to belong either to the Visa holders or the B. So we already know that A union B means the set of Visa holders or MasterCard holders. The problem is they didn't give me any information about A union B. So use this thing called an addition rule. Let me bring this up. Which tells you that A union B, the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. And I'm given this is 0.2, and I'm given these two, and I just plug them in. And I think that should be enough for to give you the answer for B. What's the probability that the selected student has neither type of card? Well, they don't have a Visa or a MasterCard. That means that they are in, you have to convert that. So it means that they have to be on the outside of the or statement. They have to be somewhere here. To be on the outside, you could use, so the easiest way is once I have the answer to this, and for my numbers, you guys have different things. So for my numbers, it turns out to be that probability of A union B is equal to 0.8. So if I know that, then I know that the probability of not, I'm using different notation. See me do that? You're supposed to use this. Not being in there, the complement, the probability of the complement of A union B is equal to 1 minus the probability of A union B. And these are in DeVore. These are in your book. So I know that it's 0.2. For me, it's 0.2, which is 0.8. All right. And then we have, so this is a question where we would ask you to directly answer this in words, like what is that the selected student has a Visa card but not a MasterCard. What does that mean? Well, inside here, it means they have a Visa card, so they're inside here, but they can't have a MasterCard. So it's going to be somewhere here. It cannot be in this overlap part. So if I draw it out, it's going to be this. It's A with B deleted. We did this in class. Or another way to say it, it's A intersect not B. Why is it that? Let's go back and look at this Venn diagram. I'm just draw it out here again. Not B is everything outside of this set. A is here. And the intersection of A and not B, everything outside of B, is this black area right here. So they're the same thing. And I believe it should be here. It's B right here for me. And how do I calculate the probability of this event? Oh, that's interesting, because if you get the first part wrong, you're going to get the second part wrong, right? So that's lovely. So in your book, they have something that says, it's in Devore, you have that this is probability of A minus probability of A intersect B. And so this is in your book in Devore, you can find it, or you can actually reason it out with the way I did with the Venn diagram up here. I'm going to let you fill in the rest. You're trying to calculate this, you know this, and you know this, so you can fill it in. And then the last one is calculate the probability that the selected student has exactly one of the two types of cards. So that means they have to be in the black area that I had drawn earlier, or this green area. Exactly means they have to be either in this one or this one. So the first one, how do I write that out? That's part E. How do I write that out? It's going to be either in A intersect B prime, which is the complement of B, or it's got to be in B intersect A prime. I don't like those primes because it makes me think of derivatives, but A intersect the complement of, or B intersect the complement of A. It's just the reverse argument. The green area, shaded area, is B intersected with not A. And so you know the answer to this from your previous problem. And if you go back to did we compute this? Well, you can compute this the same way. See if you can use the same formula. Probability of B intersect A, not A, just reverse the A and the B. It's going to be probability of B minus probability of A intersect B. So that's the probability of that part. And the probability of the union of two things, which we've done before. Oh, and by the way, these things can't happen simultaneously. You're either in one or the other, so there's no intersection and overlap of the black region and the green region. So just to remind you, it's actually in your book. Devore's chapter on this is really, really important. So what I can do is just add up the probability I get here once I crank through these to the probability I get here. And that's going to give me my probability of either being in the black or the green. So hope that helps enough for you to scratch through this.